Okay, so this is for the second day on 6.5, and this is, we've been talking about operations. This is on adding, subtracting, multiplying, radicals, and the division is actually radicals. The division is actually rationalizing the denominators. So it's on adding, subtracting, multiplying, radicals, and rationalizing the denominators. I'm going to do this mainly by examples. We will just say to simplify, say you have 3 radical 45 minus 5 radical 80 plus 4 radical 20. So you're adding or subtracting radicals. And you do want to pay attention whether or not they're square roots or cube roots, whatever. These are all square roots. You look for the largest perfect square inside. So on 45 it'd be 9. On 80, 16 times 5. And 24 times 5. So you basically, and you may have to do some scratch work out of the side, but look for the largest perfect squares inside there, and then say, okay, out of this one I can take out a 3. When you take it out, you're taking 3 times 3, 9 radical 5, minus, and then out of this you can take out a 4, so 20 radical 5. And out of this you can take out 2, so you'd have 8 radical 5. And then these are like terms. It's just like saying 9x minus 20x plus 8x. So it would be 9 minus 20 would be a negative 11, negative 11 plus 8, negative 3. And the radical 5 stays the same. Okay? Not too bad on that one. Okay, let's do one more like that. So you did 4 radical 8 plus 3 radical 50. So inside 8, yep, 4 and 2, and inside 50, yep, 25 and 2. Out of this we can take out 2, so you'd have 4 times 2 would be 8 radical 2. Yep, 15 radical 2, and then add them together, 23 radical 2. The radical stays the same, so 23 radical 2. Okay, so that's what they mean by adding or subtracting radicals. And the only ones that you can combine are the ones that have the like terms. Okay, same radical. Okay, so now let's do the multiply. Let's do a couple examples. Let's say say they give you the quantity 2 radical 3 plus 3 radical 5 times the quantity 3 minus radical 3. So it's basically like you're going to FOIL this out. And you multiply. I recommend you draw the arrows. And multiply 2 times 3 would be 6 radical 3. Multiply this. Multiply the numbers in front. It's understood there's a 1 in front here. So 2 times 1 would be negative 2. And then radical 3 times radical 3. It's just radical 9, which is 3. So that's just, you could just go ahead and say that's minus 6, or write it like that to start. And then multiply this would be plus 9 radical 5. And then multiply to have a negative 3 radical 15. Okay, so you'd have 6 radical 3 minus 6 plus 9 radical 5 minus 3 radical 15. there's nothing you can simplify in the radicals, and there's no like terms in the radicals, so that's it. That is your final answer. Combine like terms. Yep. These won't be bad. So then, let's try one more. The quantity 4 radical 2 plus 7 and 4 radical 2 minus 7. Now, you could, before I multiply this out, you could look at this and do the shortcut. Recognize this as a plus b times a minus b. If you have a plus b times a minus b, when you multiply that, you get the a squared minus ab plus ab. That drops out, minus b squared. Difference of two squares. Okay, so the shortcut is square the first one. So 4 squared is 16. Radical 2 squared is 2. 16 times 2, 32. And then square the last one, 49, and it's a minus sign in between. So minus 49, you get a negative 17. Now, that is the shortcut. Okay, if you don't like the shortcut, then you can do it this way. The long would be 16, 16, and then radical 2 times radical 2 is 32. Show you that the middle term drops out. That'd be minus 28 radical 2 plus 28 radical 2 minus 49. And you see the middle terms will drop out. Okay? So final answer is negative 17. Okay? But if you can use this shortcut, difference of two squares, square the first one minus the square of the second one. Okay, let's try this one. Say you have 5 radical 3 minus 6 times 5 radical 3 plus 6. Shortcut, 5 squared is 25. Radical 3 times radical 3 is 3. 25 times 3, 75. Minus 6 squared, 36. And if you subtract those, you get 39. Okay? Okay, then the last part will be to simplify. And this part, you might make a little note, rationalize the denominator. Okay, so if I had 2 plus radical 3 in the numerator divided by 4 minus radical 3 in the denominator. To get rid of that radical in the denominator, if there's a plus or minus sign, you always use the idea that we did up above here. You use this a squared minus b squared. So what you would want to multiply by, you look at that denominator and multiply by the 4 plus radical 3. If you multiply the denominator by 4 plus radical 3, you got to multiply the numerator times 4 plus radical 3. It's okay to have a radical up in the numerator. You just can't have it down in the denominator. Okay, so now multiply that out. So 2 times 4 would be 8. 2 times radical 3, 2 radical 3. 4 times radical 3, 4 radical 3. And then radical 3 times radical 3. 3. And then on the bottom, the shortcut is square the first one. 4 squared, 16. Radical 3 squared, 3. So that's our a squared minus b squared. Okay, combine up on top. We can combine the 8 and the 3. Ooh, yeah. We can combine the 8 and the 3 is 11. Combine the 2 radical 3 plus 4 radical 3. 6 radical 3. And then combine the bottom, we've got 13. 11 plus 6 radical 3 all over 13. Now, if you get down to something like that and all 3 of these numbers, if they have something in common, then you want to reduce it. Okay? But they don't. Okay? Okay, last example. So you have 6 and it's divided by 3 plus radical 7. So what's the conjugate of that? What do I want to multiply by? Yeah, 3 minus radical 7. Top and bottom. So we got to multiply this out. 3 times 6 would be 18. Minus 6 radical 7. Okay, now square the first one. 9 minus 7. So you'd have 18 minus 6 radical 7 all over 2. Now that one you can reduce. That's like a polynomial over a monomial. That 2 divides into both of them. Yep. That 2 divides into the 18 and into the 6. It does not change the radical 7. Okay? Okay, enough examples? Okay. Okay.